Welcome to our next lecture of the series Scheduler and Dispatcher. So students, in previous lectures, we had picked what is scheduler, what is dispatcher. We had identified that there are three kind of schedulers: long-term scheduler, short-term scheduler, mid-term scheduler. So let's have one quick review, and then I have two questions, and we will pick what is answer of these questions. So, what is long-term scheduler and where it works? Long-term scheduler works in new state. What is one working of long-term scheduler? It selects the processes from the bunch of newly created process which system wants to send for ready state or to the RAM. So, from hard disk, you want to send process to RAM. Which kind of process? New created process. So these kind of processes you want to send to the RAM, and that selection is done by long-term scheduler. Long-term scheduler identifies processes which you want to send from new state to the ready state. Now, next one is short-term scheduler. When short-term scheduler is used, now you have so many processes in your ready state. Now, out of these processes, which process, if you are having single processor, so you need to select only one process at a time. So what will be the criteria for selection? And on the basis of that criteria, you need to schedule processes accordingly. So what is the way you are going to send process from ready to running? That is done by short-term scheduler. So short-term scheduler used to send process from ready to run, means from RAM to CPU. So that is short-term scheduler. Now the third one which we had picked, that is mid-term scheduler, and we had identified that this is quite complicated. Generally, we get confused where midterm scheduler is utilized. So midterm scheduler is used to schedule processes which you have, suppose there are certain processes you have sent out from RAM. Now you have sent processes out from RAM to the hard disk, and now you want to bring those processes into RAM again. So that is now how you are going to bring processes into RAM, how you are going to select processes, that which process I should send to the hard disk. So everything is scheduled by another scheduler that is known as midterm scheduler. So it deals with swap out and swap in processes. So that is overall scheduling. Now the thing is that once we talk about long-term scheduler, mid-term scheduler, short-term scheduler, so let's try to pick with respect to one this question, and we will try to understand the name of these things, that is LTS, which is having term long term, then MTS, mid, and then STS, that is short. So why these are called long, mid, and short? Is there any reason behind it? And answer lies in this question. Which scheduler is most frequently invoked? Now, according to you, which scheduler is most frequently invoked? Can you identify that whether it is long-term, short-term, or mid-term scheduler? Frequently invoking means which scheduler works very frequently. So the answer of this thing is short-term scheduler. Short-term scheduler is most frequently invoked, and that is the main reason it is called short-term. Now the reason is why short-term scheduler. Why a short-term scheduler is most frequently invoked. Now, when we talk about long-term scheduler, what it does, it select the processes from newly created and send those processes into the ready. So, as we had picked, that it select from hard disk and send to the RAM, and it select bunch of processes and send those bunch of processes into the RAM. It's not necessary that it need to pick one process at a time and send to the RAM. It can select, suppose RAM is having 100 uh, entries, or RAM can store 100 entries. So from hard disk, you can select 100 processes and send to the RAM at one instance of time. So that is long-term scheduler. Now, once long-term scheduler has sent those processes, 100 processes, and suppose now RAM is full, now this scheduler has to wait, this LTS has to wait until and unless your RAM gets little bit free. Hence, once it will get little bit free, then only it will again get invoked. So the main thing comes, that is long-term scheduler is not that much frequent with respect to the invoking. It will get invoked after certain time once certain processes get completed and RAM got free. Then only it will send again processes to the RAM. Now, similarly, midterm scheduler will only be utilized when your RAM is full. If RAM is not full, then it will not be utilized. And if RAM is full, then according to processes, it will get selected and sent out and further sent in. So that is midterm. It will get frequently used once your RAM gets full, but otherwise there is a possibility that it will not get used. Hence, it comes after the long term. Now, what about short term? Short term, now we are focusing on process sending between RAM and CPU. And we know CPU is the fastest unit. It works very quickly. So if you had sent one process into CPU, it will execute it very quickly, and it will require another process very frequently. Hence, you require one scheduler which can schedule very frequently and send the process very quickly to the CPU. And that is the reason that this is known as short-term scheduler. So short-term scheduler is most frequently invoked because this is the scheduler which send processes for execution into the CPU. Hence, short-term scheduler is also known as CPU scheduler. So be careful. Sometimes we call it CPU scheduler. There are certain books where you will find that short-term scheduler is known as CPU scheduler, or even they have not utilized the word short-term scheduler, they use the word CPU scheduler. So I hope now it is clear that why short-term scheduler is most frequently invoked and what is the significance of long word, mid word, and short word in these schedulers. Now the second question comes, that is, which scheduler controls the degree of multiprogramming? So when we talk about degree of multiprogramming, the first question comes that what is degree of multiprogramming? What is this thing? Now degree of multiprogramming says that number of processes in RAM. Now suppose I'm saying that in RAM I can hold n number of processes. So the degree of multiprogramming is n. Degree of what is multiprogramming? Multiprogramming says that how many programs my system can execute simultaneously, or how many programs it have capability to execute. So how many programs you can execute simultaneously? The number of programs you can store in the RAM at a time. Those programs only can be executed simultaneously. Hence, it boils down to the capacity of the RAM. So if I can hold n number of programs into RAM, so I can run n number of programs parallelly or simultaneously, and that's why it is known as degree of multiprogramming. So the question comes that which scheduler controls the degree of multiprogramming? Sometimes students get confused that because short-term scheduler works on your RAM, hence this is the scheduler which controls the degree of multiprogramming, but the answer is no. Short-term scheduler does not control the degree of multiprogramming. The actual answer is long-term scheduler. Now, the thing is, why long-term scheduler? And how long-term scheduler controls the degree of multiprogramming? So, as I have said earlier, that degree of multiprogramming is that number of processes you can have in RAM and who send processes to the RAM. That is long-term scheduler. Long-term scheduler select processes from new and it send the processes to the RAM. So if long-term scheduler send X process to RAM, then only these X processes will be scheduled by short-term scheduler. It cannot schedule X plus 1. Hence, who is the prime controller? That is long-term scheduler. So I hope now it is quite clear that long-term scheduler LTS controls the degree of multiprogramming. Now, I hope that this is clear that why long-term scheduler. Once again, I'm repeating why LTS, because LTS is responsible to send a bunch of processes into the RAM. So if LTS has sent n number of processes, then only those n processes can be scheduled for the execution. So this n number will be decided by the LTS. Hence, the degree of multiprogramming will be controlled by the LTS. So I hope that we got answer of both questions and review of our short-term, long-term, mid-term scheduler. So that is all we have with respect to scheduler and dispatcher. Now, the next portion will be that, okay, we had discussed that there are scheduler, it means they are scheduling. So what are different algorithms for scheduling? And we are going to focus on short-term scheduler or CPU scheduler. So in our next lecture or series of lecture, we are going to focus on CPU scheduling. What are different algorithms? We will pick each and every algorithm and we will solve different examples of those algorithms. So today we have completed our scheduler and dispatcher, short-term, long-term, mid-term scheduler, and several primary questions related to short-term, long-term scheduler. And next we will start our CPU scheduling. So that's all for today. We will discuss CPU scheduling in our next lecture. Thank you.